Our goal in today's lesson is to begin learning how to solve linear equations. Or we could say we want to find the solutions of a given linear equation. What does it mean to be a solution of a linear equation? It's a great question, especially if we're supposed to be finding these things. So let's define what it means to be a solution. A solution of a linear equation is the value of the variable that makes the equation true. So let me show you a couple quick examples of what it means to be a solution of an equation. First of all, let's show that x equals 3 is a solution of the equation x plus 7 equals 10. Well, when we're given a number which is supposedly a solution of an equation, we simply need to plug in that numerical value to see if the resulting equation is true. So I'm going to take x plus 7 equals 10, which was the equation that was given to me, and I'm going to plug in x equals 3 for x. When I do that, my equation becomes 3 plus 7 equals 10, or 10 equals 10, because 3 plus 7 is 10. Well, 10 equals 10 is a true statement. So x equals 3 is definitely a solution of the equation x plus 7 equals 10. Let's look at a second example of this type really quickly. Let's show that x equals negative 3 is a solution of the equation 8x minus 14 equals negative 38. Well, again, to show that negative 3 is a solution of the equation that we were given, we simply replace the x by negative 3, we simplify the equation as much as we can, and we see if what results is true. So I started with 8x minus 14 equals negative 38. I plug in negative 3 for x. And when I do that, I get 8 times negative 3 minus 14 equals negative 38. Now let's simplify that left-hand side just a bit. 8 times negative 3 is negative 24. Then I have to subtract the 14. Negative 24 minus 14 is negative 38. The left-hand side is negative 38. The right-hand side is negative 38. Excellent. That's a true equation or a true statement, and therefore x equals negative 3 is a solution of the original equation. Well, before we go anywhere, let me point out that not every number I choose for x is going to be a solution of that equation. So let's show that x equals 1 is not a solution of the equation 8x minus 14 equals negative 38. Well, what do I do to check? Well, I plug in the 1 for x, and I get 8 times 1 minus 14 equals negative 38. Well, 8 times 1 is just 8. So the left-hand side is 8 minus 14. The right-hand side is still negative 38. That means that the left-hand side is now negative 6. The right-hand side is negative 38. Is negative 6 equal to negative 38? Of course not. And that means that x equals 1 is not a solution of the equation that we started with. Now, I'd like us to consider how we would actually find the solutions of these linear equations ourselves. After all, it's a lot more difficult to go find the solution than just to be handed it. The first few examples we've done in our lesson now, we were actually told what the solution is. It's perfectly fine to check those solutions, but the real difficulty with the algebra is to go find those solutions. Now, I said difficulty. It's not really that difficult. We just need to walk through the process in order to solve our linear equations. So I want to start by looking at problems that are often called one-step equations. Now, solving one-step equations is the name given to finding solutions where the linear equations really only need one extra step to solve them. So let me show you a couple of examples of one-step equations. Let's start by solving x minus 5 equals 17. So I have my equation, x minus 5 equals 17. In order to solve that equation, we need to find a solution or a number for x which makes the equation true. Now, I could just start plugging numbers in for x to check. Some people would call that guess and check. And that's okay, but our equations are going to get pretty complicated, so we don't want to just try that. To actually solve this equation, I want to get the x by itself on the left-hand side of the equation. So the question is, how can I get that x by itself legally? In other words, what math can I do to get the x by itself? I mean, there are lots of things we could do to get the x by itself. For example, we could just take an eraser on our pencil and erase the -5 on the left-hand side, and we'd be left with x equals 17. But that's not legal from a mathematical point of view. You wouldn't get the correct solution. So we need to think about how to get the x by itself, or to isolate the x on that left-hand side so that we can get our solution. Well, the correct thing to do to get x by itself is to add 5 to both sides of the equation. By adding 5, I'm going to be able to get rid of the -5 that's on the left-hand side of the equation. So let's do it together. I started with x minus 5 equals 17, and now I want to add 5 to both sides. I want you to notice that this is sort of like taking a seesaw that's already level and adding 5 pounds on one side or 5 pounds on the other side. If the seesaw was level to start and you add 5 pounds on both sides, it'll stay level. And that's exactly what you want these equations to do as you start to solve them. You want both sides to stay equal throughout the process. So we're going to add 5 to both sides of our equation. And when I do that on the left, x minus 5 plus 5 is just going to become x. Okay, it becomes x plus 0 because minus 5 plus 5 is 0. That's just x though. And then I have 17 plus 5 on the right-hand side, and 17 plus 5 becomes 22. So what's the equation now say? It says x equals 22. The equation actually tells us the solution. The solution is 22. Now we should check that we've got the right solution, especially since we're sort of new at this. So how would we check that 22 is the solution? Well, we'll go back to the original equation and we'll plug 22 in for x, and we'll see if what comes out is a true equation. So the original equation was x minus 5 equals 17. We plug in 22 for x. 22 minus 5 equals 17. And 22 minus 5 is 17. So the equation says 17 equals 17. Is that a true statement? Yes. Fabulous. So indeed, x equals 22 was a correct solution for that equation. I want you to notice that this was called a one-step equation because we really only needed one step to solve it. And that one step was the addition of plus 5 to both sides of the equation. Now, let's look at a second example of this one-step equation type. I want us to solve t plus 4 equals 19. Now again, you could just plug in numbers for t, but let's do it by solving the equation rather than just plugging numbers in randomly. So I'm looking for a number that I'm going to plug in for t to make the equation true. I want to get the t by itself, or isolate the t. And I need to do that, again, in a mathematical way that's allowable, that actually makes sense. Well, we might start by subtracting 19 from both sides of the equation. That's actually a perfectly legal thing to do from a mathematical perspective. So you start with t plus 4 equals 19, and you subtract 19 from both sides of the equation. Great. What do you get? Well, on the left-hand side, you have t plus 4 minus 19. Well, what is that going to be? That's going to be t minus 15. 4 minus 19 is negative 15. So t plus 4 minus 19 is t minus 15. That's my left-hand side. Now, what do I get on the right-hand side? Well, I get 19 minus 19, which is 0. So my new equation is t minus 15 equals 0. Now, that's a perfectly correct equation to state at this point. The problem is it didn't isolate the t at all. That was my goal, was to get t by itself, and we didn't accomplish that. So we could work with the equation that we just had, but I'd rather we went back to the original equation and did something else. Again, what we did was okay, it just didn't get us to the goal of isolating the t, or getting t by itself. Well, what would you do then? T plus 4 equals 19 is our equation. how would you get rid of that plus 4 that's on the left-hand side with the t? Well, what's the opposite of addition or adding 4? It would be to subtract 4. So I'm going to suggest that we take t plus 4 equals 19 and subtract 4 from both sides of the equation. And once you do that, some really great things are going to happen. First of all, what happens on the left-hand side? Well, notice that the plus 4 minus 4, they cancel each other out. And the left-hand side becomes t plus 0, which is really just t. In fact, we'll just quit saying t plus 0 or x plus 0. We'll just start writing it as t or x. So my left-hand side here is t. What's the right-hand side? Well, it's 19 minus 4. That simplifies to 15. And therefore, after we've completed this subtraction, our solution is t equals 15. Well, you could go back again to the original equation, t plus 4 equals 19, and plug in t equals 15 to see if the result is true. Remember, that's what it means to be a solution, is that you can plug in the number and make the original equation true. If you do that in this case, you'll have 15 plus 4 equals 19, which is the same as 19 equals 19. And that's definitely true. If you've got $19 and I've got $19, we've got the same amount of money. So indeed, t equals 15 is a solution of that equation. I'd like to show you more examples of solving one-step equations now, which are going to look a bit different from the ones we've just done. So let's move to the next example. I want us to solve 8y equals 104. 8y equals 104. Now that's a linear equation. It's a perfectly good linear equation. This time there is mathematics around, or numbers around the y, but in this case I've multiplied by an 8 rather than adding or subtracting. I still want to get the variable by itself. In this case I want to get the y by itself. And by getting the y by itself, I'll have my solution. So what do I have to do? I've got to get rid of the 8. How do I get rid of that 8? Again, I could just erase it with my pencil, but that's not legal to do. How would I get rid of the 8? Well, the answer is definitely not addition or not subtraction as before, because the 8 here is not added or subtracted from the y. So what could I do to get rid of the 8? Well, here's the answer. The 8 is being multiplied with the y. What's the opposite of multiplication? The answer is division. So let's take our equation, 8y equals 104, and divide both sides by 8. Remember, if you're going to divide the left-hand side by 8, you have to divide the right-hand side by 8 as well to keep the equation balanced on both sides. Now, what happens when you do that? When you divide by 8 on the left-hand side, the 8's simply cancel, and you have y, or 1y, if you want to write it that way. I would just write it as y. So the left-hand side now just has y on it. Great. Now, I've isolated my y, but I need to go look at the right-hand side now. What does the right-hand side look like? Well, it's the fraction 104 divided by 8. Now, it'd really be good to simplify that as much as we could, so let's do that together very quickly. 104 and 8 are both even, so they both have a 2 in them. If I factor a 2 out of the numerator, I'll be left with 52 times 2. If I factor a 2 out of the denominator, I'll have 4 times 2. I can then cancel those 2's, and I have 52 over 4. The same kind of process will allow me to reduce 52 over 4 to 26 over 2. And 26 and 2 are both even, so I can reduce again, and I'll be left with 13 over 1, or just 13. What does the equation then become? It becomes y equals 13. And that means that y equals 13 is our solution. You could check that if you wanted by taking the 13 and plugging it back into the original equation and then seeing if what comes out is a true equation. Well, let's do one last one-step solution example by doing the following. Let's solve 5/3 times x equals 55. Well, as with the example that we just did, we want to isolate the variable here. In this case, that's x. So what's in the way? What's next to the x? It's the fraction 5/3. Now, how am I going to get rid of that 5/3? Again, I'm not going to add or subtract because the 5/3 is being multiplied with the x. I need to undo that multiplication by dividing by 5/3. Now, I don't know about you, but dividing by a fraction, that feels a little uncomfortable. It's perfectly legal to do, it's perfectly okay to do, but I like to think of it instead as multiplying by the reciprocal. In this case, the reciprocal of 5/3 is 3/5. So, instead of dividing by 5/3, let's multiply both sides of the equation by 3/5. Now, what is that going to give us? Well, before we start doing any simplification, we're going to have 3/5 times 5/3 times x equals 3/5 times 55. Remember, if you're going to multiply the left-hand side by 3/5, you must multiply the right-hand side by 3/5 as well. Now, what happens if you simplify? Well, the 3/5 times the 5/3, they're just going to cancel each other. And the left-hand side then will just be 1x, which I'll just write as x. Well, we've isolated the x. That's fabulous. So now I just need to simplify the right-hand side. Well, what is the right-hand side? It's 3/5 times 55. Okay, can we simplify that at all? Sure we can. What is going to happen between the 5 that's in the denominator of the 3/5 and the 55? They're going to cancel a little bit. In fact, if you write the 55 as 55 over 1, you'll see that the 5 and the 55 can cancel a bit, and you'll be left with 3 over 1 times 11 over 1, which is 33 over 1, or 33. What does that mean? It means that we have x on the left equals 33. That's our solution. Well, let's check it a bit. We had to do some real mathematics there to get to that x equals 33, so let's check. We take our original equation, 5/3 x equals 55. We substitute 33 in for x, and we get 5/3 times 33 equals 55. We can reduce the left-hand side a bit by canceling the 3 with the 33, and we'll have 5 over 1 times 11 is 55, and 5 over 1 times 11 is 5 over 1 times 11 over 1, which is 55 over 1, or 55. We have the equation 55 equals 55, and that's definitely a true statement. So here's a tip that you should keep in mind as you're solving one-step equations. You need to look for the opposite function. If you've got multiplication in the problem, do the opposite, which is division. If it looks like a number is being added to the variable, do the opposite, do some subtraction. That rule will help us as we move on to what are known as two-step equations. So I'd like to transition now to what are known as two-step equations and solve such equations. For example, what if we had an equation like 3x minus 4 equals 6? Now I want you to notice something. If you wanted to get the x by itself, if you wanted to isolate the x, you'd have to get rid of the 3 and the 4 in order to do so. That means that two steps are required, hence the name two-step equations. So let's talk about how we would solve 3x minus 4 equals 6. First, we need to get rid of that 4. And you might say, why the 4 and not the 3? Well, believe it or not, the answer is wrapped up in the order of operations. To isolate the x, we first have to undo the multiplication by 3 and the subtraction of the 4 in reverse order. And so I'm going to start by getting rid of the 4 first. Now to do that, what would I do to get rid of a minus 4 like that? I would add 4 to both sides. And if I do that, the left-hand side becomes just 3x because the minus 4 and the plus 4 cancel each other out. What does the right-hand side become? It becomes 6 plus 4, which is 10. And so the new equation, which is still balanced compared to the original equation, is 3x equals 10. Notice we're now down to a one-step problem. We whittled it down from 2 to 1 step. Well, how do we get rid of that 3? Well, we know how to do that. We divide both sides by 3 or multiply both sides by 1/3, however you want to view it. And if you do that, the left-hand side becomes 3x over 3. Cancellation gives you x. And the right-hand side becomes 10 over 3, or 10/3. There's no reducing you can do to that fraction, so your solution is just 10/3. Now, we should check. to make sure that that solution makes sense, so let's do so. We go back to the original equation, 3x minus 4 equals 6, and we replace the x by 10/3. And that gives us 3 times 10/3 minus 4 equals 6. 3 times 10/3 is what we do next, thanks to our order of operations, and that, of course, is just 10. So I have 10 minus 4, which is 6, and of course 10 minus 4 is 6. So I get 6 equals 6, which is definitely a true statement. Well, let's look at another two-step equation. I think it's good to do some practice with these sorts of things. So let's solve another two-step equation which is a little more complicated. At least it looks like it's more complicated as we start it. Let's solve t over 8 plus 1 equals 5. Now, two steps are definitely needed again because you've got to get rid of the plus 1 and the 8. So how do we do that? Well, let's start by getting rid of the plus 1. Now, how would we get rid of a plus 1? Well, I need to do the opposite of addition, and that's going to be subtraction. So I'm going to subtract 1 from the left-hand side of the equation. If I do that, I've got to subtract 1 from the other side of the equation as well. When I do that, I'm going to have the plus 1 minus 1 cancel each other out, and the left-hand side becomes t over 8. The right-hand side is just 5 minus 1, or 4. So I've got the equation now, t over 8 equals 4. And now we're down again to a one-step equation. But I've got to get rid of that 8. Actually, by the way, it's really a 1/8 because t over 8 is the same as 1/8 times t. But that's okay. Let's not fret over that too much. Let's just multiply both sides by 8, and let's see what happens. So we have t over 8 equals 4, and we multiply both sides by 8. Now, what does that do to the left-hand side? Well, notice that those 8s are actually going to cancel each other. That's exactly why I multiplied by 8. And when they cancel, I get t over 1, which of course is just t. Now, what does the right-hand side do? Well, it's 8 times 4, which is just 32. So my final equation is t equals 32, which means the equation tells me the solution. T equals 32. So 32 is the solution. Now, we've checked several solutions throughout this lesson, so I'm going to leave it to you today to check to make sure that 32 really is the solution. It's very, very important to check those things because you want to make sure you didn't make a mistake in your arithmetic or in your operations. So I'll leave it to you today to check that, but indeed, that really is the solution. Well, I want to move to a word problem now. We haven't really done any word problems in this lesson up to this point, so I want to move to a word problem that involves solving a two-step equation. So let's set up the problem, let's first state it, and then we'll try to write it into some algebraic statements. So here we go. Imagine that Mary has a mail order business where she sells books of some sort, and let's say that each book costs $3 plus your shipping cost, which is $5 on any order. So the books are $3 each, and then there's just a flat shipping rate of $5 on any order. We want to write an equation that describes the amount spent as a function of the number of books purchased. That'll be our first step. And then once we've done that, I want us to determine how many books we can purchase if we have $50. Okay. Let's start by building the equation. We certainly weren't given an equation, we just had a whole bunch of words and numbers floating around. So what's the first thing we do when we're handed a word problem like this and we need to actually set it up algebraically? We must start by naming some variables. Well, notice that no variables were given to us, so we need to come up with them on our own. So I suggest the following. Let's let B equal the number of books that we purchase, and let's let A be the total amount of money that we spend. Okay. Once that's done, we now need to interpret the English sentences that we were given into algebraic expressions, into an equation. Well, each book costs $3. So the total cost for B books is going to be 3 times B before we add the shipping. Let's step back a bit. Let's say you bought 2 books, then the total cost for just that would be 3 times 2 or $6 before shipping. If you bought 10 books, the total cost for that would be 3 times 10 or $30 before shipping. So if you bought B books, the total number is 3 times B for your cost for the books before shipping. Well, we need to add the shipping in. So how much is that going to change my algebraic expression? Well, the shipping cost is $5 added on to the cost of the books for any order. It doesn't depend on how many books you buy. 1 book or 1,000 books, your shipping cost is just $5. So, in order to get our total cost, or the total amount that we'll spend, we need to take the 3B, which was the cost for the books themselves, and add 5. And that addition of 5 is going to be for the shipping. That is the total cost for us. And therefore, A, which is the amount of money we're going to spend totally, equals 3B plus 5. There's your equation. A equals 3B plus 5. And it's excellent that we pulled that off. That's not an easy thing to convert from the English phrases to an algebraic equation. But that's great that we got that far. Now we need to worry about the second part of the problem. We were told that we wanted to find out the number of books that we could purchase if we had $50 for them. Now, here's a question. Does that $50 represent A, the amount of money that we're going to spend, or B, the number of books? You should always ask this kind of question. And you know, we weren't told in the problem that 50 was either A or B. In fact, the problem didn't even say anything about A or B when we started. So we have to decide, does that $50 represent A or B? Well, $50 is going to be the total amount of money that we spend. And since we named our variables at the beginning and we declared what they stood for, it's pretty easy to look back and say, that 50 is the value for A. So if we go back to our equation, which said that A equaled 3B plus 5, we can replace the A with 50, or plug 50 in for A. And once we've done that, our equation becomes 50 equals 3B plus 5. Now, you know, equalities, you can switch both sides if you want. So instead of writing 50 equals 3B plus 5, I can also write 3B plus 5 equals 50. It's just like looking at a seesaw from one side and then from the other. It's going to look the same, except for switching around. So I'm going to rewrite it as 3B plus 5 equals 50, basically just to get the variable on the left-hand side. And now I want to solve for B. Why? Because the problem was asking, how many books can I buy with $50? And B is the number of books that I can buy. So I want to solve 3B plus 5 equals 50 for B. Well, that's a two-step equation. We've done several of those already in this lesson. So let's get B by itself. How would I do so? Well, the first thing I'm going to do is get rid of that 5, that plus 5 on the left-hand side. And how do I get rid of a plus 5? I subtract 5. But I have to make sure I do it on both sides in order to balance everything out. When I do that, the left-hand side becomes 3B. The right-hand side is 50 minus 5, which is just 45. And my equation is now 3B equals 45. Now what do? Well, I've got to get rid of that 3. How do I do so? I divide both sides of the equation by 3. And when I do that, the left-hand side will have the 3's just cancel, and I just get B, which is what I wanted. And the right-hand side is 45 divided by 3. Now, does that simplify? In fact, it does. If you check, 3 does divide into 45 evenly, and you're left with 15 when you simplify 45 over 3. And the new equation is B equals 15. Now, we could just stop there and on our paper circle B equals 15 and happily get up and leave. But we really ought to stop and ask ourselves, what in the world does B equals 15 mean? Well, in the context of this problem, B was the number of books that we could buy. And therefore, B equals 15 means we can buy 15 books if the amount of money we have to spend is $50. Well, today we've learned how to solve a number of types of linear equations, but we're not done with this theme. Solving equations like these is extremely important in algebra, and so we'll spend more time on linear equations in our next lesson.